Hello everyone, welcome to amELECTRICAL YouTube channel. I hope you all are good and safe. Today in this video, we will discuss about the working principle of transformer. Every concept on this topic will be cleared, so try to concentrate on the words of whatever I am going to tell you now. Here I want to ensure you that if you watch this video till end, then definitely you will get a crystal clear concept on this topic. In the previous video, we have discussed about the different features of transformer. If you have not seen this video, you can watch it by clicking the link showing in the I button above. In this video, we will discuss about the working principle of transformer, that means about the job of a transformer. Now the question is, what is the job of a transformer? The main job of a transformer is to convert electrical energy from primary winding to the secondary, which we have already discussed in the basic detail and type of transformer, the first video of this series. Now, what is energy? Energy is nothing but the power multiplied by time. And power is voltage multiple of current. Now, current will automatically be present if there is voltage difference. The supply voltage is already present and the next target is to induce some voltage so the load connected to the secondary winding gets the required current. Now the rest process and how the EMF is being induced we will discuss in depth, so listen carefully. Basically, the transformer principle is mainly based on the principle of mutual induction. But there are total 4 laws involved in this working principle. They are Amperes circuital law, right hand thumb rule, Faraday's law of electromagnetic induction, and the fourth one, Lenz's law, respectively. Now we will get the overall idea where the 4 laws are involved, so the rest portion of this video will be more interesting. As soon as we are connecting the supply with one winding, then I1 starts flowing through N1 and flux phi1 is being produced, which is being done obeying the Amperes law. Now the phi1 flux is here flowing upward, which is in accordance of a right hand thumb rule. And secondary side E2 EMF is being induced by Faraday's law of electromagnetic induction. This is the overall idea. Now we will discuss them one by one. According to Amperes law, if there is a current carrying conductor, then a magnetic field will be automatically generated around that conductor of intensity H. Where H is the magnetic field intensity in ampere per meter. Converse of this formula is also true. That means if there is a magnetic field around the conductor, then a current will start flowing through the conductor. Look here, this is the conductor carrying I amount of current. And this is the magnetic flux of ring shape type shown here in greenish yellow color. Now we will see the mathematical representation of Amperes law. The mathematical representation of Amperes law will be like this. If the length of the magnetic field is L, then if we integrate from 0 to L, the magnetic field intensity H dot dl, where dl is a small length, equal to mmf, that is Ni, where n is the number of turns. Here we have shown one conductor. In case of n number of conductor, if there is, then it will be n into multiply by current I, which is in ampere turns. Now as h is a constant, it will be out from the integration. So we will integrate the small length dl from 0 to L. This integration will result L. That means it will be h dot L equal to n multiply by I. The overall formula of h will be equal to ni by L. If n equal to 1, as he has shown only one conductor, in that case our number of conductor will be 1, then it will be h equal to I by L, that is ampere per meter. Here, when the current is present, then the flux direction, and when the flux is present, then the generated current direction will be decided by the right hand thumb rule. Now, case 1. When the conductor is straight, then thumb represent the current direction and the rest 4 fingers represent the flux direction. You can see here. And in case 2, when the conductor is circular type, which is in case of transformer, then the thumb will represent the flux direction and the rest fingers will represent the current direction, which is flowing through the transformer winding. The Paradis law of electromagnetic induction states like this: the rate of change of flux linkage with respect to time, that is d phi dt, is directly proportional to the EMF, that is E, induced in a conductor or coil, that is E varies as d phi dt. E equal to minus n d phi dt, where E is the induced EMF, n is the number of turns, d phi is change in flux and dt is change in time. Here the negative sign is just because of Lenz's law. In this video, just after few seconds, we will discuss about this law, then you will get this point clearly. So, according to this principle, an EMF is induced in a coil if it links a changing flux. Now the question is, what does the term changing flux means? As the supply voltage is alternating in nature, here you can see the voltage is changing with respect to time at each point. As the supply voltage is sinusoidal, that means alternating in nature, so the primary winding current IP and the flux is also be alternating in nature. So, as the flux is also changing with respect to time at each point, that's why the term changing flux is mentioned. Now we will go for depth discussion of working process step by step. Initially, the load is not connected. First, we are connecting the primary winding, whose number of turns is N1, with the supply voltage Vs, and I1 current starts flowing. According to this law of Ampere, the flux phi1 is being generated by the influence of MMF N1 I1, that is ampere-turn, and its direction is upward, which is being decided by the right hand rule. Then this phi1 flux is linking the secondary winding, and E2 EMF is being induced by Faraday's law of electromagnetic induction. When this flux is linking the primary winding, then it's inducing the E1 amount of EMF in the primary coil. Here the load is not connected. As we are connecting the load, if the load impedance is ZL, then E2 by ZL equal to I2 amount of current starts flowing through the load via this winding of N2 number of turns. See the polarity here on primary and secondary side both. At primary, the current is entering the polarity, and at output port, the current I2 is leaving this polarity. The term polarity is very important here, especially when we are connecting the transformers in parallel. As I2 current is flowing through the N2 number of turns, then according to the principle of Lenz, due to this ampere-turn N2I2, a cancelling flux phi2 will be generated. Cancelling means phi2 is in opposite direction of phi1. Now question is, what Lenz's law states? According to this law, an induced EMF always gives rise to a current whose magnetic field opposes the change in original magnetic flux. Now this flux phi2 will also link the primary and secondary winding. So it will also induce some EMF, say E1' and E2' in primary and secondary winding respectively. Listen carefully. What's happening here is, first, due to phi1, E1 was induced in primary, and now again due to phi2, E1' is being induced in the same primary winding, but in opposite direction. So the resultant EMF is E1 minus E1', which is less than E1. So the difference between the supply voltage Vs and EMF is increasing. As the potential difference is increasing in primary side, so the current I1 will also increase. Now the increased amount of current, that is the extra current, will again generate the extra flux, which is here phi3. This phi3 will nullify the phi2. This way, as long as the secondary side will produce some cancelling flux, the primary side will also produce some flux which will nullify the cancelling flux. So as a result, the initially produced flux phi1 will be the resultant flux, here called main flux. Here the load voltage mentioned is VL. This is up to today's video. Watch the full lecture series one by one. You need not to go anywhere. Here only you will get a full subject knowledge. I hope your concept is clear now. Please inform us by doing a comment whether your doubt is clear or not. You can rewatch this video for more clarity. Till if you have any doubt regarding this topic or any other topic related to electrical engineering, then drop your doubt in the comment section below. Remember, one like, one inspiration. If you have learned something new in this video, then hit the like button and subscribe the channel. You can contact us. Every detail is given in the description section. Thank you for listening me today. We will meet soon with a new interesting topic. Till then, take care, be safe, be protected from coronavirus. Goodbye.